you very much. Bonjour. Well, this will be my last word in French. I would like to introduce myself, Yves Coppens, and I am a visiting scholar. It's written here. I would like first to thank Courtney Ross, of course, for her invitation, for her generosity, and to congratulate her for what she has built that I didn't know, and for the clever reason she has founded and conducted this institute and school. It happens that I met Courtney and François the Pope, almost together. We actually met, as a matter of fact, in Roma at the Pontifical Academy of Sciences in the beautiful pavilion, La Casa Pio IV, in the middle of the Vatican Gardens. It was a holy appointment. Well, thank you, Courtney, anyway. Thank you very much. If I understood well, we have here to talk together about what to teach to the children of the Rose School and how. As far as I am concerned, as I am a paleontologist, I will try to talk to you about life, history of life, man, history of man, and their future. I would say, first of all, that it is important for anyone, I think, to start by the largest perspective before proposing any prospective. And as I am dealing with time, I would suggest to start with the beginning, not the beginning of universe, of our universe that we don't know. It's an open question, say the scientist. I love that. When you can hear scientists say it's an open question, it's a beautiful way to say that he doesn't know anything about that. So it's an adaptation, but with the origin of light, the origin of photon, what is called the Big Bang, and what John Mather, that I met a few years ago, by the way, dated at 13.7 billion years old, let's say 14 billion years old, as Pierre-Lena told you. The matter is then described as very dense, very hot, very bright, very disorganized. And since this moment, which moment? The matter called inert matter became less and less dense, less and less bright, and also like a paradox. Please remember that. Like a paradox, more and more organized, but more and more complex. It's interesting because we will find this paradox all the way to man. And we are today still moving in the same direction, more and more organization, more and more complexity. The frame of 14 billion years is, I think, important to start with, because everything following the Big Bang, man, us included, will be inside this frame. So it's just a frame. 14 billion years, not too much. In comparison with 15 billion, for instance. I will not tell you that the history of inert matter, more and more organized and more complex, evolving through successively quarks, particles, electrons, protons, atoms, molecules. I don't know enough about that. It is not my job. I am only telling you what I learned or what I think I understood from the astrophysicians. Pierre. These colleagues are also saying that in space are appearing sort of enormous structure looking like big pancakes. Pancakes, you know what it is here. And it is the division of these pancakes which are the origin of galaxies. And it is from galaxies that stars were born. It's amazing, eh? 4.6 billion years ago. In the galaxy beautifully called the Milky Way, was born a star and its system of planets and comets, an important star for us, the Sun, and an important system, the solar system. Our planet, the Earth, is of course one of the planets of this system, obviously born like the Sun 4.6 something billion years ago. Without any atmosphere at the beginning, gas was coming from the Earth itself, and water from the comets falling on the Earth. Half a billion years after she was born, the Earth was born, the Earth was having her oceans as well as her atmosphere, with, of course, a completely different composition as our current atmosphere. 98% of CO2, calcium carbonate, and the complement being mostly nitrogen. But the temperature was then around 200 degrees centigrade, which was not the case yesterday. What is important for teaching this first part, I think, about teaching, it is that time has been calculated, that we are dealing with a calendar, that consequently we can have an idea, a good idea, of the thickness of time, the deepness of time. That in this universe, everything is changing all the time, but that the physical laws stay the same. That, in that sense, the universe, our universe, is looking more or less like an homogeneous object, a sort of entity, what Pierre was saying. And of course, that thanks to the size and the mass of our star, the Sun, thanks to the size and the mass of our planet, the Earth, thanks to their distance, 150 million of kilometers, we kept our water and our atmosphere, and for the moment, a stable gravitation, partly thanks to the moon. Thank you, the moon. But the moon is currently supposed to move, which is a bit embarrassing. Earth, as we already said, is 4.6 billion years old, a little more than that. As soon as 4 billion, maybe 3.8 million years old, billion years old, the physical condition of our planet were such that she will be in a position to move again towards more organization, more complexity. In water, on the Earth, a more complex organization of molecules create cells, cells with an inside and an outside, cells able to exchange matter and energy between themselves and with outside, cells able of reproduction with more and more rules, RNA, protein, DNA, cells able to adapt themselves to different environments, and this is very new. So what is important for teaching, again, in this new event? That everything is changing all the time. Everything is changing all the time, even climate. That to the first paradox, more and more organization, more and more complexity, is emerging a second paradox coming as an addition to the first, more diversity, biodiversity, but more control, heredity. It's amazing to have this sort of opposition. That the history of the universe, the history of the matter, is inventing new objects all the time, new processes, and that the transformation of the inert matter into the living matter, the organic matter, is an important sort of discontinuity inside the same continuity. Sometimes more is different. Sometimes more is different. More organization of molecules made different objects, cells, with completely new characteristics. It's a very strange story. Well, for me. For about 2 billion years, life has been only documented by unicellular beings, all of them in water. But as soon as 2 billion years ago, these beings becoming more complex, more organized, became pluricellular. Their diversity is increasing, and it is the time of emergence of many new organisms, many new phyla, algae, invertebrates, archaea, and as soon as 550 million years ago, first vertebrates with a skeleton inside the body and still in water. We will have to wait 100 billion years again, around 450 million years ago, to see plants first, vertebrates after, invertebrates in between, leaving the water from time to time, and then adapt their organism, their body, their physiology, their habits to a permanent life outside the water, on the continents, only 450 million years ago, in the atmosphere. The very first footprints of a terrestrial vertebrate are 360,000 years old and come from an island west of Ireland, if I know the last result. So what are the meanings of this event for teaching? Again, that the beginning of the history of the Earth is mineral. Remember that, because we are not thinking too much about that. Only mineral for at least 600 million of years. Mineral with life in water for 3,400 million years. That is to say 4 billion years of an Earth with mineral and water landscapes, not at all biologized on the continent themselves. Biologization of the continents has been a terrible pollution, bringing a lot of oxygen, which at that time was a poison. The Earth, which was a beautiful planet, gray and blue, became a completely different one, blue and green, ugly for the Cambrian eyes. The famous green, look at the green, that today we love, is only 500 million years old. So it's a question of relativity. I love the green, you know, but I love the rocks too. The meaning is also that adaptability of life is tremendous and admirable. Inventing the length and the quadruped locomotion is looking like an odd idea and a successful achievement. The phyletic way to reach primates and hominids is obviously the one passing through the amphibians, some batracians, some reptiles, and some mammals, mammals laying eggs first, and mammals with placenta only afterwards. Among the placenta mammals, some 70,000 years ago, is emerging from some insectivores a new group about 70 million years ago, happy to have found a new ecological niche, the angiosperm, trees with flowers, which means trees with fruits. So in a way, our origin, the primates, is thanks to trees and fruits, which is nice, and flowers. Adaptation of the primates to this niche can be demonstrated through many anatomical new features. Their eyes closer to each other and on the front of the face instead of being on the side like that. Don't know very much, well, this way. To have a stereoscopic vision, a 3D vision, to be able to appreciate the distances, the depths, to jump. Eyes, as far as we interpret well enough, or we understood well enough, the anatomy of their orbits, able to see colors, which is useful when you are having to eat fruits. Nails instead of claws. Opposability of the first finger, hands and feet, to the other ones for grasping the branches and climbing the trees. So this is in a way our origin. And then among the primates are emerging new primates, apes, in tropical Africa 10 million years ago only, called hominids, which will happen to be the common ancestor of pre-chimpanzees and chimpanzees, pre-humans and humans. And because of climatic changes and for consecutive environmental reasons, the descendants, the children of these common ancestors have been divided into two groups. There is no other explanation. One group in a very covered environment, forests, and one group in a much less covered environment, open forest and savanna and even grassland. And that's all. You have the common ancestor, the hominids, and descendants, children, which are some of them in covered places, some others in less covered places. And that's all. The first group became the pre-chimpanzees, ancestors of chimpanzees, called the panini, very well adapted to covered countries, knuckle walkers and climbers, eating fruits, nuts, insects, and very specialized since 10 million years. And the second group became the pre-humans and the humans, called the homininae, adapted to much more open countries, trees, and grasslands, still eating fruits in the trees, but eating also roots on the ground. And for this reason, having adopted this very strange, very odd, permanent standing posture. Look at me. How strange it is to be just on two legs and having your forearm just pending. Fortunately, I have pockets. Well, it's strange anyway. And consequently, a double locomotion, walking as a biped, and still climbing as an arboricole. And this is really the beginning of our closer history. We stand and stay upright. And this new posture was at the origin of a lot, of course, of anatomical, physiological, probably psychological, why not, and behavioral transformation, inventions, emergences. What to teach about that? That only because of a climatic change and a change by chance of the environment, beings were able to adapt themselves to these new conditions to survive, able to become very creative, even if they have to manage with what they have and a few more mutations. I mean that they have their own hereditaire suitcase and some mutations to help. And as far as hominina, us, are concerned, the solution that we found was to stand on 2 feet instead of 4. And new posture have in the same line, the new posture is erect posture, have in the same line the trunk, the pelvis, the thigh, the leg. Was of course at the origin of semi-free hands, because they are still used in climbing, but also able to be employed in many more uses. A new position of the skull on the rachis, new curvature of the rachis itself for the equilibrium, cervical lordosis, thoracic kyphosis, lumbar lordosis, sacrokyphosis, again. New structure of the pelvis, less high and wider, which means a conflict between posture and parturition, and the beginning of the anti-ischiatic way to deliver the child, typical of women and not at all of apes. New orientation of the femora to reach the axis of gravity, passing at the level of the femiotibial joint. And of course, new structure of the brain for it to be able to drive the whole revolution of this transformation. But their body, the body of these pre-humans, remains small, as well as their brain. We have 3 genera and 4 species of hominid to demonstrate this phase. Sahelanthropus chadensis, 7 million years old, from Chad, called also Tumai, that I co-signed with Michel Brunet. Ororhine tugonensis, 6 million years old, from Kenya, that I co-signed, thank you, with Brigitte Senu. And Ardipithecus cadaba and Ardipithecus ramidus, both from Ethiopia, the first 5.6, 5.8 million years old, the second 4.4 million years old, that I have not co-signed with Tim White. And if I am speaking of 10 million years old instead of 7, the year of Sahelanthropus, it's because the transformation of the environment, it's opening according to the C4 plants in the enamel of Kenyan vertebrate teeth, is appearing as soon as 9 to 10 million years. So the opening is also there 10 million years ago, even if the first fossil that we have to demonstrate that is Sahelanthropus, only, if I can say, 7 million years old. Examples, few examples. Ardipithecus ramidus, which was beautifully described by Tim White and his team in Science in 2009, something like that, in 11 papers, beautiful description. Its pelvis is typically a pelvis of climber in its lower part, powerful relief for powerful muscles, and a pelvis of walker in its upper part. It's amazing, eh? The way nature is doing sort of composite bones. The big toe of its feet is divergent, able to opposability to climb, but a little bone, the peroneum, os peroneum, remains in the tendon of the first rear, of the first toe of the foot, used for having a more rigid foot and easy walking. The hand has a very powerful muscle equipment for walking even on their palms, for instance, as a very elegant, as also a very elegant and flexible equipment to grasp. That's for Ardipithecus. Another example, Aurorine tugenensis. Aurorine tugenensis has femur, with a relief called the gluteal tuberosity, which is the beginning of a linea aspera. Linea aspera is just a small relief on the bone for the attachment of a strong gluteus maximus. And the gluteus maximus, I'm sorry, I don't know the right word in English, but it's just the bottom. The bottom is done with three muscles: gluteus minimus, gluteus medius, gluteus maximus. And only man and woman have a big, well, a larger gluteus maximus, and it's a question of equilibrium of the body is the reason why we have this sort of strange thing behind. But Aurorine has also a strong crest for the muscle brachioradialis on the humerus, typical of the equipment of a climber. So again, Aurorine with his femora is showing the way to stand, and Aurorine with the humerus is very clearly a climbing being. So how to use that for teaching? Probably in saying that life, by natural selection, is trying to survive whatever would be the importance of the climatic change and whatever would be the effort and the inventivity to find a solution. It's a great lesson. 4 billion years ago, still in tropical Africa, the climatic change started around 10 million years ago, is increasing. It's probably the same climatic change, but only with steps. The proboscideans, the animal with the trunk, for instance, which were eating leaves, Stegotetrabelodon, Primates, Anancus, became extinct. No more leaves, not enough. And the proboscideans eating grasses like elephant, like mammutus, the first mammutus were African and not from Siberia, are emerging. And in the same way, Ardipithecus, Sahelanthropus, or Horine are disappearing. Prehumans still protected by the forest, and which for this reason are quite small and do not have a strong sexual dimorphism. I mean that the first prehumans are still very small and don't have important sexual dimorphism, which is a sign of protection of the forest, even if the forest is a clear forest, not a very thick forest, not a very dense forest. It's a forest anyway and a protection anyway. And are appearing Australopithecus, the famous Australopithecus and Kenyanthropus, more aggressive, walking and running better, still climbing, except one, and having a strong sexual dimorphism this time, meaning that they are less protected and more exposed to predation, to predators. It's the time of, sorry for the names, but you know, it's their names. It's the time of Australopithecus Barel-Ghazali from Chad, 3.5 million years old, that I co-sign, thank you. Australopithecus afarensis from 3.2 to 3.8 million years old, from Ethiopia called Lucy, that I co-sign. Australopithecus prometheus, 3 million years old, from South Africa, called also Littlefoot. Kenyanthropus platyops, 3.5 million years old, from Kenya, with a flat face. We love that. When it's quite close to human, the face, instead of having a prognatism, is much flatter. And Australopithecus anamensis, 4 million years old, from Kenya and Ethiopia, which doesn't climb anymore for the first time. For the first time, this Australopithecus seems to be only walking. So from 3 to 2 million years ago, still in tropical Africa, the same climatic change started 10 million years ago, you remember, is increasing again in such a way that it is looking this time like a true drought, I have worked extensively on that particular phase, and I can give you, for example, these measurements, this quantification. When you count the number of pollens of trees and the number of pollen of grasses, if you do with them a sort of fraction, number of pollen of trees on number of pollen of grasses, if you have a high figure, it's more trees, and if you have a low figure, it's more grasses. Well, you got a figure of 0.4 at 3 million years, and 0.01 at 2 million years. Psh, no trees anymore, not much anyway. not many. All the animals that I collected during 10 years in southern Ethiopia, and I collected 50 tons of bones, 50 tons. I brought them to Paris. It was a difficulty to find a place. These animals show the same thing, I mean a tendency to adapt themselves to this drought. New diet, new exposition to the predators. The elephants, for instance, increase about 4 times the size of their molars because eating grass is wearing much more than the teeth than eating leaves. For the same reason, the rhinos, the equids, the suids are increasing the heights of their incisors and the length and number of cuspides of their tubercles, of their molars. The equids are also transforming their legs, and instead of running on 3 toes, like the hipparions, they are now running faster on 1 toe, which is a true horse. You know, when the scenery is open, when the landscape is open, you have really to be careful because you can be seen easily by the carnivores. So it's better to climb when there are trees, or to run when you don't have any more trees. And the hominids, our family, are of course beautifully behaving in the same way, and they found 5 solutions to the crisis. Congratulations to the family. 5 solutions. First solution, a robust form in the Afar, and only in the Afar. Australopithecus gari, long hind limbs, very big teeth, prognathous projected face, but small brain. Number 2, a sequence of robust form in Eastern Africa, south of Ethiopia, Kenya, Tanzania, Malawi. Paranthropus aethiopicus, that I cosine. Paranthropus boisei, very robust, very specialized dentition, small anterior cutting teeth and enormous post-canine chewing molars, but small brain. Number 3, it's the diversity is beautiful. Diversity according to ecological niches, of course. Well, nature is very creative, very inventive. Number 3, a robust form in South Africa, Paranthropus robustus, robust body and dentition specialized, a bit like the Eastern African one, but small brain. Number 4, a sequence of small forms in South Africa, Australopithecus africanus, Australopithecus sediba, walking and running better, still climbing, but still small brain. I think that you understand already. And number 5, and at last, a small form in East Africa, Homo habilis, the first man walking much better, running much better, not climbing anymore, with a new dentition to eat anything, even meat, and for the first time with a much bigger brain. Here we are. More complicated, more convolutions, better irrigated according to the prints of the vessels on the bone of the brain case. And it is amazing to think that this brain is no more at the beginning that a natural selection for the small Homo to be able to survive in finding new strategy to escape at the predation. That's all. The bigger brain had the same function, the same role as the tooth of the elephant or the toe of the horse, and no more. But sometimes more is different. Again, it's a funny story. More brain brought to man the very new possibility to think better, to reach a new level of reflection, like in a mirror, of thinking, to anticipate actions, and consequently, for the first time, to make at least stone tools, which are sculpture. Well, when you have a stone and you take a stone inside, it's a sculpture. Symbols, I guess that it's since the beginning there are symbols and real tools made for something. Altogether, I want to say that man is man as soon as he's man. It seems obvious, but it's something important to understand that man is man as soon as he's man. I mean with technical, intellectual, spiritual, aesthetics, ethics, facets, since the beginning. There is, when you follow the history of man, there is no more discontinuity. So Homo is Homo, man is man, as soon as he's man. I mean that I think, I cannot demonstrate that, but I think that this facet of intellectual, spiritual, aesthetic, ethics are there since 2.5, 3 million years. 3 million years. And his evolution will become this constant exchange between the thoughts, the hands, and the articulated language. He talk like me today. After having seen with inert matter this paradox of more organization by more complexity, with living matter, this second paradox, completing the first, more diversification but more control, heredity, we are adding here, and it's very important for the genus Homo, for man, a third one, more organization, more complexity, more diversification, more control, more freedom, but also the responsibility which is going with it. More freedom and more responsible. This is important for our purpose. And here we are. So how to use that step for teachers? Claiming that the genus Homo, man, appeared by necessity to adapt himself to a climatic change. That's all. Just as his neighbors, the elephant, the Swede, the rhino, the horse. But as his adaptation had chosen the brain and not the tooth and not the foot, a different level of complexity of the brain did change everything. The more complex brain done for finding strategy to survive became able to think, to ask questions about himself, his origin, his destiny, his death, the universe, and so on. It's funny, eh? We have just a little more brain to try to escape the predation. And now the brain is, as you can see, when I look at you, it's obvious, are thinking at so many other things that to escape predation. My grandmother, her grandmother, from my mother's mother, she was from Brittany, used to tell me, if you, my grandson, is descending from the apes, me, your grandmother, surely not. But it's not because of his animal origin that man has not won his freedom, his responsibility, his dignity. And my grandmother was at the same time right and wrong. And this is what I wanted to tell you today. Thank you very much.